Systems of linear inequalities. So we've looked at systems of equations. Let's look at what happens if we have a system of linear inequalities. For example, solve the following system. 2x minus 3y is less than or equal to 12, x plus 5y is less than or equal to 20, and x is greater than 0. Now this is a system with 3 inequalities. Often we'll just have 2, but I wanted to at least show you one where we have 3. Okay, so the first thing we're going to do is take the first inequality and graph. In order to graph it, what we do is we replace the inequality with an equal sign, get y by itself, and then graph using a solid or dashed line, and then use a test point to shade the appropriate side. So the first inequality that I wrote was 2x minus 3y is less than or equal to 12. I'm going to make it an equation. So 2x minus 3y equals 12. And I want to get y by itself. So let's move 2x over to the right-hand side. Negative 3y equals negative 2x plus 12. Divide everything by negative 3. Y equals 2/3 x minus 4. So negative 4 is the y-intercept, and our slope is 2/3. I go up 2 and write 3. The inequality symbol has an equal bar, so that means I will draw this line with a solid line. So here's my solid line. It's greater than or equal to, so I'm going to shade above, but if you are unsure, pick a test point. For example, 0, 0, and see if it makes the inequality true. If it does, you know you're shading the correct side. So here's my shading. Then repeat that step for the second inequality. So our second inequality was x plus 5y is less than or equal to 20. Let's make it an equation and get y by itself by moving x to the right-hand side. So 5y equals negative x plus 20. Divide everything by 5. Y equals negative 1/5 x plus 4. So 4 is the y-intercept. Negative 1/5 is the slope. So now I'm going to graph this line. And again, this one has a solid line because it has an equal bar. So I already have my blue line and shading. I now have my green line, and the shading will be less than. So I have already see where I have some overlap, but don't forget we had 3 inequalities. So let's repeat again. My third inequality is x is greater than 0. So make it an equation. X equals 0. Okay, that is a vertical line at x equals 0, or the y-axis. So I already have the blue shading, the green shading, and now I'm adding in the shading to show where all the x's are greater than 0. So that's on the right-hand side. And I definitely have shading of all 3 colors. And the solution is that region where all the shading overlaps. So here you can see the solution region shaded in. This one's a bounded region because I have lines on all 3 sides. I have a triangle. And often it's important to find the vertices, or sometimes. Okay, so the vertices are formed where 2 inequalities or 2 lines intersect. So we're going to use systems of equations. So for example, this vertex is where 2x minus 3y equals 12 and x plus 5y equals 20 intersect. I'm going to multiply the second equation by 2 and by negative 2 and use elimination. So first equation stays the same. Second equation becomes negative 2x minus 10y equals negative 40. Add the equations. X's cancel. Negative 13y equals negative 28. Divide. Yes, we have messy fractions. Y is 28 over 13. Let's find x. So plug it into one of the equations. X plus 5 times 28 over 13 equals 20. Okay, you would have a calculator, and we could calculate that x is equal to 120 over 13. That means that at first vertex I have as a dot is 120 over 13, comma 28 over 13. Let's find the red vertex. This is at the intersection of 2x minus 3y equals 12 and x equals 0. Okay, because x equals 0 is one variable by itself, let's just substitute in. I can put 0 in for x in the first equation. So 2 times 0 minus 3y equals 12. Negative 3y equals 12. Or y equals negative 4. So that red vertex is the point 0, comma negative 4. Third vertex in blue, it's the intersection of x plus 5y equals 20 and x equals 0. Again, use substitution. 0 plus 5y equals 20, or 5y equals 20, or y equals 4. So 0, comma positive 4. Those are my three vertices. Okay, so that was an example with 3 inequalities. Most of the time, you're going to see 2 inequalities. So let's look at this system. 2x minus y is greater than negative 3, and 4x plus y is less than 5. Okay, so take the first inequality, make it an equation. 2x minus y equals negative 3. Move the x's to the right-hand side. Negative y equals negative 2x minus 3, or y equals 2x plus 3. My y-intercept is 3. My slope is 2, or 2 over 1. I have no equal bar, so it will be a dashed or dotted line. So my line looks like this blue line. My shading, if I choose a test point like the origin, will be below. So shading below. Okay, now take my second inequality, make it an equation. 4x plus y equals 5. Move the x's to the right-hand side. Y equals negative 4x plus 5. Y-intercept is 5. Slope is negative 4, or negative 4 over 1. Okay, again, I have a dashed line because there's no equal bar. So I already have my blue line and shading. Now I have my green line. Notice how they're both dotted or dashed. Green shading is below as well and to the left. Again, choose a test point like the origin, 0, 0. If I plug it in, does it make that second inequality true? If it does, I know I shade on the side where the origin is. Okay. So the solution here is unbounded, or not completely closed in. So I don't have a full triangle because this bottom part of the triangle goes on forever. There's no definite closing off point. Let's look at one more example. Solve this system. X minus y is less than or equal to negative 2. X minus y is greater than or equal to 2. Okay, take my first inequality, make it an equation. X minus y equals negative 2. Move my x's to the right-hand side. Negative y equals negative x minus 2. Or y equals positive x plus 2. Y-intercept is 2. Slope is 1, or 1 over 1. I have an equal bar, so it will be a solid line. So graphing, here's my blue line. If I choose the origin, it would not make my inequality true, so I'm going to shade above this line. Make the second inequality an equation, so x minus y equals positive 2. Move my x to the other side, negative y equals negative x plus 2, or y equals x minus 2. Y-intercept is negative 2. Slope again is 1 over 1. Okay, again, it's a solid line. So I already have my blue line in shading. Here's my green line. If I choose the origin, so does 0 minus 0, is that greater than or equal to 2? No, it's not. So shade away from the origin. Now we see that there is no overlap. That means that there is no solution to this system of inequalities.